Welcome to Security Architecture Podcast, where we help cybersecurity professionals to stay ahead of the curve and ensure they are successful in their cybersecurity journey.
Hi, I'm Evgeny.
Hi, I'm Dimitri.
We have Paul here from IBOSS. Paul, can you please introduce yourself and the company?
Yeah, absolutely. Yeah, it's good to be here. My name's Paul Martini. I'm the CEO and CTO of IBOSS. Just a quick background on IBOSS. So we deliver network security as a service through the cloud. So think of proxy appliances or firewall appliances. Basically the same capabilities, but SaaS delivered, just the same as you would get Netflix. We're trying to eliminate the DVD player.
So what's the name of the offering that's addressing the outbound browsing?
Yeah, so the platform is called IBOSS, and basically at a high level, users are always connected to the service. So think of users working from home or working in an office. They all connect their network data through the cloud service so that you can perform all the proxy functions and cybersecurity functions, as well as compliance within the platform before the traffic gets to any business application or even the public cloud to prevent malware, enforce compliance, and prevent data loss.
Is there a name of the offering, like you'll just call IBOSS for everything, or there's a particular naming convention for different products inside the company?
Yeah, we keep it simple. So yeah, it's just IBOSS. That's the name of the platform. It's the name of the company as
Gotcha.
well.
Very easy. So the SASE acronym that was created by Gartner last year is encompassing a lot of different parts. You know, the outbound browsing, remote access, zero trust, SD-WAN. Which part of the platform you guys capture?
We like to think we have, we're, as a SASE platform, we're covering the core of what SASE is all about. And actually, you know, we have over 200 issued and pending patents, worldwide patents that cover really the use and the delivery of SASE platforms. But for us, we think the device is the new network perimeter. So we don't care what network the device is connected to. It could be your home, it could be an office. The network begins and ends at the device itself. And so the idea here is that if the device is the new network perimeter, what we're dealing with is connecting those users directly to the cloud applications as quickly and as direct as possible. So we cover anything that has to do with network traffic that goes between a user and any destination on the internet. That's business and public destinations. Although SASE covers some other cases like software-defined perimeter, we really don't focus too much on anything that connects people to buildings. You know, in our view, we believe in the future, the buildings are going to go away. The notion of sitting in your conference room in an office is really no different than sitting in your office at home. You don't know what network you're connected to. In the office conference room, you could be on the neighbor's Wi-Fi. So as long as your traffic is running through the service, you can ensure that you have the adequate cybersecurity protection as well as compliance protection at all times.
It's kind of the reality for the last 2 months. Now we all work from home.
Yeah, I can tell you there's a lot of customers who, you know, they moved to our platform and they're connected to the service, even large customers, 50,000 employees, that when users went home, nothing changed for them. They had no issues, no downtime. You know, unlike, you know, traditional models which have appliances, network security appliances, you have to send the network data through those appliances which sit in the office or in the data center. So you can imagine that organizations that didn't have SASE or didn't use a SaaS-based model were oversaturating their networks because the home users have over 100 megabit, 500 megabit, or a gigabit of bandwidth at home. And you can imagine if you have 1,000 users working from home with 1,000 megabit, that's a terabit of bandwidth. I don't think most people have that bandwidth at their data center.
There's a lot of, I guess, talk on the market that vendors take appliances, put them in a cloud, and call it SASE. So we want to learn about how you mature your product and how you're describing the maturity of your product.
Yeah, I think, you know, when you think about, I like to equate this to other spaces, right? When Netflix came out, replacing DVD players and replacing, you know, Blockbuster video, and at the time you really didn't think Blockbuster video, it's not even around anymore. Could be, anyone could compete. But the idea here is that everybody knows that cloud is the future, and SaaS delivery of every application, including network security, is the future. So most vendors want to meet that requirement, and so they label their products as a cloud product and as a SaaS product. But what they're really doing is using appliances and sticking them in data centers and connecting selling that as a service. The difference is, if you think about Netflix, any company can get videos and DVD players and infrastructure and stick it in data centers and load it up with movies. It doesn't make them Netflix. What makes Netflix is the software. It's a single service. You can sign up in 60 seconds. You can connect to it and watch movies from anywhere, your hotel room, on the road. It follows you wherever you go. It's the software that makes SaaS. And I think there's a difference between infrastructure as a service, where you put, even as a customer, you can put servers and appliances inside of Amazon, and SaaS, which means you connect to the service and it just works and does what you need it to do. So basically, SaaS gives you the value, instant value, without all the overhead. And so I think that a lot of vendors, there's very few vendors I think that have a mature global cloud footprint, because to connect users to cloud applications, you need to follow them wherever they go and give them fast connections. So what that means is you need the software and you need the footprint, the global cloud service to be global and everywhere. And very few vendors have that. So we see a combination of some vendors putting virtual appliances inside of Google, some are putting it inside of Amazon, calling it a SaaS service. They don't really own the fabric and own the software as well as the infrastructure within the data centers.
How will you license your product? Is it based on seats, devices, concurrent connections, bandwidth?
Yeah, so we keep it pretty simple. The way we do this is you pick from 3 packages. The core is really compliance. The second package is malware defense, and the third package is data loss prevention. So you're going to pick from core, malware, or data loss. Malware and data loss include the previous packages. So malware will include the core, and data loss will include malware and core. So you pick one of the 3 packages. You tell us the number of devices you have, and we give you a price. So the nice thing about that is that no matter how much bandwidth those users consume, let's say all the users go home and they're doing a terabit of bandwidth per second, your price doesn't go up. But unlike in an appliance world, you would have to spec out the appliances, buy the infrastructure, and you're talking about very expensive infrastructure at this point that you would have to host, manage. So we give you the flat price. Users can consume as much as they need to, accessing business applications and public internet, as well as as a network administrator or security administrator, you can apply as many rules, policies that you want. You can even do decryption, so we can inspect encrypted HTTPS content. Mm-hmm. If you want to decrypt the entire internet, it's not going to take down your network because you didn't have enough.
But that's a bit different topic, I guess. So based on the licenses, from what I'm understanding, it's per user, and it also has different levels of defense, right? That you can apply.
Yeah, we actually switched. Yeah, so we used to use users. We switched to devices. And the reason for that. Yeah, the reason we use devices is not everything breathes. Not everything's a human being. Right. IoT is a big deal, and so it's an easy way to price.
How would you know a user has 5 devices, 2 devices, or more?
Well, what we do is we count the number of devices, and actually sometimes provided by the customer as well, and then we give you a price. And then we understand that users may have more than one device, so we calibrate our price so that it meets the exact kind of thresholds that you would get from a user-based pricing, but it makes it easier to understand.
Understood. So, as example, if I have a mobile phone and I have a laptop, you would charge me for 2 devices.
Exactly. There would be 2 devices there, but the price is calibrated, so it would look very similar to a user-based price.
Okay, let's jump to the architecture part and talk about your global architecture. How you guys created your cloud architecture, high availability, presence, where do you guys present, regions, networks, clouds? And I know you're already sharing a slide.
Yeah, absolutely. Yeah, and I think that this part is really important. And before I go, and I'm going to cover the details here for the architecture, remember, you're connected to a service, and the service is what handles all of what I'm going to talk about. So you're not managing or creating or doing anything with these containers I'm going to talk about. The service is doing that, but it actually is our architecture that we believe that makes all the difference in our ability to deliver 100% of any feature that you could get with a proxy appliance and any feature that you can get inside the next-gen firewall. We believe that the containerized architecture that I'm going to talk about is what makes that possible, as well as lowering speeds and doing all that kind of stuff. And as you look at here, I just did a general evolution of how we got to where we're at today. You know, initially it was putting more features in an appliance, consolidation of features in an appliance, you know, for budgeting and other things, just ease of management, less gear. And then the second phase is the sales, you know, protecting the mobile users, the sales force, the person that the road warrior working remote. So you still have your appliances, but you have, you know, a cloud offering to cover the mobile use case. And then the SASE use case here is who isn't remote. I mean, now with COVID and everything else, there is no notion of someone in the office, or not everybody's using cloud applications. And it's been proven now that has to happen due to unpredictability in environments. And so we're now sitting, what we believe is we were entering the SASE era in 2019 heavily, and then actually it just catapulted to right down the center. So we believe that think of the things you were trying to accomplish with appliances to reduce complexity and reduce costs. But now as you get to SASE, you do that even further because you completely eliminate the appliance, but you still get all the benefits. And then as you look at our kind of like how this sits, and I'm going to show the next slide here, which goes deeper into the architecture, is your users go remote, the applications go to the cloud. The purpose of this platform, IBOSS, is to get anything you can do in the proxy appliance and move it over into the cloud as a SaaS offering, meaning you're not going to lose any of the features, the capabilities, or anything like that. The only thing you're going to lose is the appliance. It's the same movies without the DVD player. And now you have users consuming bandwidth at infinite amounts, encrypted traffic. We have infinite scale in the cloud. So we can decrypt, we can scan, and you as a network administrator or security administrator don't have to worry about load or all the things that you've done 100 times over, like racking and stacking gear and dealing with slow connections. We handle that for you.
What public cloud provider you support?
So we actually built our cloud footprint. So we operate in data centers all over the world, depending on the region. You're going to see things like Equinix and others where we partner. We build our infrastructure and our software in those data centers, but those are internet peering points. If you look at PeeringDB, we're the most peered. We believe the largest, most peered network security fabric now on the market, servicing the largest organizations. So here's a little bit deeper on that architecture. So think of any device. We really don't care of the type of the device that it is. Any network. You could be in the office. You could be at home. It's all the same to us. You're always connected to the network security service before going out to the internet. This could be business applications, public internet. It doesn't matter. It's kind of interesting here when we think about the public cloud and the internet. A lot of people think of CASB, which is an area that we cover, which covers business applications. But you know, the reality is when people work from home, they're not picking up malware from Office 365. They're picking, using the trusted business applications. It's more than likely they're picking up a virus from a public site that has untrusted malware on there. So unfortunately, they need an internet connection to get to your business applications. So we're protecting all of it. Anything leaving the device going to the internet. Now, as the data goes into the service, it's processed by one of many containerized gateways. It's software, but these cubes represent containerized gateway capacity that runs in our global data centers. And actually, this is all automatic, so you don't manage the containers or do anything like that. But what containerized architecture allows us to do is not only process and protect your data as it goes to the service within our data centers with horizontal scaling, meaning infinite amount of processing power and bandwidth, but it allows us to stretch into a multi-cloud environment to protect other assets in other clouds in a seamless way. For example, as you think about Azure, we're one of 2 trusted security partners we co-develop with Microsoft. Instead of shipping the service into Azure, what we do is we stretch the containerized capacity natively into Azure so that if you have servers that need to go out to the internet, instead of sending their data back to our data centers, the gateways will process and scrub your data directly in Azure and then send it out to its destination, which reduces the outbound cost because typically you pay the meters anytime the traffic leaves Azure. You don't have to pay that meter, you pay us. And really, as you think about containerization with any engine, what that means is that we run our engines, malware engines, our feeds, but also we can encapsulate any malware engine and feed into this model. And we've done that with FireEye, for example, where we've containerized the software to deliver it in the cloud. You can add this as an add-on. It's 100% of the FireEye NX capabilities delivered as a cloud service for users anywhere they go. But containerization allowed us to do this because we can containerize that technology just like we do the malware engines and extend capabilities beyond just 1 or 2 or 3 malware vendors and feeds. We believe the more feeds you get, the more malware engines, the better. And actually, the last thing here is if you see Verizon. Verizon, it's a white labeled product. They call it the Verizon Secure Cloud Gateway. It's powered by IBOSS. We stretch into Verizon. So we can secure Verizon enterprise users when they sell connectivity, secure connectivity to protect those connections as well. If you do have private cloud, this is a private cloud data center. We believe we're the most hybrid version. We'll talk more about that later, in that we can stretch containerized capacity into physical appliance form so that it protects users on-prem if you need to drop in, replace proxies and things like that, and you don't have time to really redirect the traffic to the cloud, or you want to reduce risk. The nice thing is the cloud sees everything as a data center, so you just become one of many data centers here. So we think that containers. Yep.
Paul, quick question. I see IoT on the list. So
Yep.
how is the IoT device will be able to route the traffic to your global any cloud security data centers?
Yeah, that's a great question. It's important that the traffic makes it through us before going out to the cloud. And there's a few methods of getting data to the cloud service. If it's your network, you can, like branch office or headquarters, you can use GRE or IPsec
So
tunnels.
we'll talk about this. We have particular questions about offices and mobile, so we can maybe leave the IoT later on to these questions if you want. Okay.
Yeah, no, I'll just at a high level, the way people ask this question all the time, at a very high level, you need to get the data through the service. The most popular way to do it is with agents, because the agents can capture all the traffic off the device and send it to the service, no matter where it's a zero trust model. And then the alternative is tunnels, and we'll talk more about that later. But GRE and IPsec tunnels, where you can just tunnel the data.
Great. Any other slides here?
Yeah,
on architecture?
there's one more. Yeah, there's one more I'll show. But containerization, I take another kind of deeper dive here, because I think the containerization is really important. And we use an alternative here just as an example with Zscaler. But this is the same for pretty much every other vendor other than IBOSS. We have global data center presence, just like the alternative. We own and operate the infrastructure, just like the alternative. That infrastructure is multi-tenant, just like the alternative. This is where all the similarities end and the differences begin. In our platform, we use containerization to create containerized gateways in software automatically to separate traffic from customer A and customer B. So we tightly control the data path. In the alternative solution, there's large non-containerized gateways that mix the traffic from customer A and customer B through the exact same gateway path and the data path. This nuance has major implications when moving to a cloud SaaS delivery service. And it's the reason why we believe that we're the only solution that can deliver all of the firewall and proxy capabilities natively as a SaaS offering. So some examples here is when we process this data, there's 2 types of traffic. There's flows and streams, like firewall, and proxy, which is proxy traffic, which is files. Unzip a file, tell me if there's malware in there. We need a way for the streams, we need a way to separate traffic from customer A and customer B so that we can run intrusion prevention, for example. We run intrusion prevention right at this containerized edge for this customer in software. We know that it's this customer because we've isolated them to containerized gateway capacity. Very difficult to run IPS here because the traffic can be people's homes from 2 customers. So this is anonymous, and you can't tell the difference between one source address and another. It's fully encrypted. So it's hard to run an IPS on raw traffic here. When we NAT the traffic, when it goes out to the internet, we NAT it to the IP address that belongs to this customer. That doesn't change. These IP addresses always belong to customer B. These IP addresses always belong to customer A, which means you can use those IP addresses to create ACLs and IP login restrictions. So I don't want you to log into my Office 365 unless you come from these IP addresses, basically through the service. You can do that very easily here because these IP addresses aren't shared. When the natting happens here and proxy, it's any of these customers. You can't use those to protect logins to applications because it could be any customer using the service that would make it through those ACLs. And then other things like packet capture. We run packet capture here. You can't run packet capture here. And I want to point out what's important here, not just with horizontal scaling and other things, is that all of this is automatic. As a customer, you're not managing this, you're not using this, you're not even seeing this. What you experience is fast connections. And then as an administrator, network administrator, what you find is that any question that you have that you can do in an appliance scenario, you find that this can do as well because of this containerized architecture. And I think that's what makes us very unique.
Thank you.
It brings us to the next question, which is related to user identity and support for multi-factor authentication, as well as how would you configure different users in the organization, such as developers, such as administrative workers, such as executive team members.
Yeah, absolutely. I think that there's two types of authentication. There's authentication for the administrators logging into the platform, and there's authentication for the end users that actually are being protected by the platform. And so to log into the interface, we support MFA as well as our login, but we also support SAML and any external IDP for login to the administrator. And then for the customer, the end users that are being protected, we support SAML as well, in addition to what we call our Gen 4, which allows us to connect users to the cloud service automatically by piggybacking on top of the trusted credentials that they use to log into the computer. So if they log into the computer with their Active Directory or Azure AD credentials, we can use that identity to log them in without prompting the user. It makes the experience really nice and easy. And then also we use horizontal scaling from those devices so they get not only fast speeds, but there's no interruptions with we use stateless tunneling. So there's no interruptions as that user jumps from network to network.
The next question is about how would you scale your infrastructure for customer demands? I mean, I'm sure that you just experienced it as part of the COVID-19 situation. What's your way to make sure that you're indefinitely scalable? And you mentioned that before. We all understand, especially if you're running your own data center, it relies on some level of hardware, right? So how you're planning these capacities, how you're scaling it up?
Yeah, so to start, the first thing is if you're using appliances, there's just no way that this is sustainable, right? It's not just the throughput of the appliance, but it's also the connectivity to your data center. If your data center doesn't have, right? But when you look at our solution and our platform, it goes back to that question you had earlier, which is, what's the difference between putting appliances in a cloud and calling it a cloud service? There's no way that would ever scale. You have to create more appliances and virtual appliances and things like that. In our cloud fabric, we use containerization to create, think of them as microservices.
What kind of technology you're using if it's public information for that purpose?
So we built, that's what we've built. So if you look at our, even on our website, you can see the list of patents. That's what the 200 patents are covering. But it's using the standard concepts. We didn't invent containerization. Right. Containerization just became popular. But actually, we have fully issued patents around containerization for the use of network security, but we use the word nodes. And actually, we were doing containerization before containerization was a term. And what we like about what's happened with containerization is it reinforced that our architecture was the right architecture because it's now being used in search engines, databases. And so when we see patterns like that, we know we're making the right decisions. But realistically, when you think about scaling, all of this is in software. So we're measuring latency here at the containerized edge for that particular customer and this customer. And then what we do is we horizontally and automatically add more containerized software capacity to process the load. That could be anything from bandwidth, web requests per second, decryption. We're measuring all of that. And then also, because it's automatic and it's all in software and we have global data center presence, we can do this very quickly and automatically anywhere the user is at any scale. I mean, actually, in a non-containerized environment, it actually becomes a lot harder because as more and more users, they may hit the same gateway, even though they may have capacity. If you get 1,000 that just happen to hit this gateway, you're going to experience a small blip of latency. Whereas this will never happen here because we're controlling the data path. We're doing the horizontal scaling from the endpoint itself. So the endpoint is fanning out and hitting many containerized gateways and choosing the lowest path as it works so that we can get the highest.
And these containers are isolated for the specific customer of yours, right? So if I'm customer A and there's customer B, my traffic will always go through the containers that you define for me with my rules, with my configuration. There will never be other customers' traffic passing through these containers, and you can horizontally scale them. Maybe it's too low-level questions, but how fast is to spin up a new container in your environment?
It's within seconds. Within seconds.
Okay.
And actually, the other nice thing about this as well is we talk about speed, but if you think about security, we're not mixing traffic between customers,
of course.
Which is there's a private key that you need to do decryption. To decrypt HTTPS, you need a private SSL key. We're storing that inside the container, which means that there's it's peer-to-peer replicated private key, which means that we don't want to mix and decrypt your keys because that something could happen there. So there's security implications to this as well as isolation.
Of course. And that's actually bringing me to the next question, right? How do you make the user experience faster and better in this case, right? And this mostly focuses on your agent. And from my assumption right now, from what you just told me, that there will be a separate certificate that will be bundled with the agent for the specific customers, right? So every single customer of yours will have a different certificate to encrypt it, so you can decrypt the traffic, right? With the full trust of the CA authority that you have in these containers.
Well, 100% different certificates. Also, if you have your own certificates, you can use those. They'll be stored that's really nice because you can move off appliances faster. And then also, I would say that when we're measuring latency, we're measuring it here at the containerized edge, so we're keeping the speed really fast while keeping security intact.
Are we doing any optimization at the edge level? Or you have some type of cache or anything like that inside the agent itself, or it's always going to the container to make the decision?
Yeah, so we basically, what we've done is we said all of the functions need to happen in the SaaS service. The agent is only responsible for redirecting the traffic. That way, when we do, what we want is everybody to have a consistent experience. So if you're on iOS or Android or Windows, you're going to have the same experience because all the job of that agent is to redirect it to the service. And so we do caching here in the service. We optimize. We also compress in the service as well. We'll take advantage of proxy. And then also, you can also redirect traffic with tunnels, and we'll talk about that later. But one of the reasons that agents are also popular, besides the fact that it doesn't matter where the user is that they install the root certificate, they take care of usernames, groups for dynamic policy, and connect the users to the cloud. And then finally, the big one is, and we're one of the few services that can do this, is we grab all the traffic on the device and we transparently send it. Meaning, it's not just your proxy traffic. People put proxy settings in a browser, but that's just web browsing traffic. We grab all of the traffic that leaves that device, transparently send it as if the user was sitting in the office. That's SSH, RDP.
So TCP, UDP, any other ICMP protocol, everything will go through you.
Yeah, primarily today what we focus on is TCP.
Okay.
And we basically force the device to use the TCP connection.
So let's talk about how you route traffic from the offices. Yeah,
so basically, when you have an office, you control the network, right? It's your router, your switches. So you have a choice. You have additional choices. One is you can create a GRE or IPsec tunnel from your routers and switches. And actually, the choice for the GRE or IPsec is really just based off your equipment. Remember, the traffic was going to go to the internet anyways. So there's no GRE or IPsec, whether it's encrypted or not, it doesn't make much of a difference.
Is there a speed difference between GRE and IPsec on your side?
Yeah, typically not on our side, but on the customer side, because the equipment, if it has to encrypt, it's going to make their edge equipment slower, right? It could be, depending on what type of gear is in place for the customer premise equipment. But I think the choice is really GRE or IPsec based off what the equipment supports. Some support both, others support only IPsec, and others support GRE. That's how they choose. But remember, you can also, for on-prem, you can also have proxy, you can also use agents, and you can also use private cloud. And I think the private cloud is a good option as well for situations. I'll show you what it looks like here. But situations where you don't want to change your network just yet because there's too much IoT, maybe there's things going on, but you want to get a cloud service tomorrow. What we can do is we can do a drop-in replacement of a chassis. This is containerized gateway capacity in these blades, which extends the cloud into your data center. And what that means here is that when you're looking at at our data center presence here, these dots, you become a dot on this map. No one else can use it. It just happens to be private data center, right?
So here's a quick question to you. If I'm in Europe and I want to browse to US, I'm guessing I'm hitting first my private cloud, if I'm private cloud, or your public cloud. From where
that's the benefit here, right? So you have a private cloud here. The platform sees private cloud as just another data center. So what happens is if we go back to this diagram here, notice we have different clouds here.
Mm-hmm.
That appliance is that cloud. So
you're actually
going to
traffic go from the appliance to the internet, or it's going to traverse you? Do you have like an internal network, for example?
Right from the private appliance to the internet.
Okay.
It's containerized capacity. But here's the thing. Here's the trick to this. Containerization allows us to do this. Is that just like we stretch across other clouds? When you have an appliance, we've stretched into your private data center. So the containerized gateway capacity and software is peer-to-peer linked to all of the global capacity. So what that means is when you set a policy. So let's go back to this this example that we had here. When you set a policy here, we're just peering that policy, the keys, the certificates, everything to the private cloud too. So the end user experience is exactly the same. If you're using private cloud, you get the benefits of protecting remote users all over the world, and actually eventually unplug the power.
What happens if my private cloud capacity reach out of, basically there's no more space, they're out of capacity?
It's just another data center. So actually it'll leverage the public cloud to get there as well. So our cloud, we see this as just another cube. And that's important because when people talk about hybrid, they feel that sometimes they don't get the same policies, the same experience, the same security, but using this architecture where we didn't send you the service, we extended the containerized capacity into your data center, you have the same protection experience and everything about it is exactly the same. Literally, even if you unplug the power of the chassis eventually, because you're going to do that, you've already moved to the cloud and you didn't even realize it. You've benefited from all the dots. Nothing has changed for the user. So it's a really nice strategy to very quickly get to a cloud.
So what's the benefit to have it? Like why would I want to have a chassis in my data center if eventually it's it's all the same. I'm using the same separation from the other customers in your cloud. Why would they like to do that? Is it like a regulation type of things, or it's risk management?
Let me give you some examples. So typically what you do is you connect to the SaaS service. What I would recommend, deploy the agents through Active Directory or MDM, and you're done. Everything's done for you. You can scale, you can follow users. Secondly, you could create tunnels. So you can go in and create tunnels from your firewall. But in some scenarios, what we find, especially these complex networks, is the network topology is very complicated. And there's no route out to the internet from that network, and they're using traditional proxies. So what this allows them to say is, look, we can get you within 24 hours. We'll drop and replace right in the spot of where your traditional appliance-based proxies are. And now you've been converted to the cloud. We'll offload all of your remote users immediately. And then you can start offloading the users over time. So that way you don't have to worry about reconstructing the network, but you can get to the cloud service very quickly within a day.
What about SD-WAN? Do you partner with end vendors? Can you do provisioning with SD-WAN? Can you make it faster to provision with SD-WAN to roll out faster?
Yeah, the way we look at it is these blue lines are SD-WAN. The way we look at SD-WAN is SD-WAN connects your offices to each other. Yes, it falls into some SASE model, but really it's think about what SASE is really all about, is a world with no buildings, no perimeters, where the zero trust, right? So technically, in my opinion, SD-WAN is a needed technology that will be around for the next 4 or 5 years, but the need to connect, it's only thriving currently because it's replacing expensive MPLS links.
But you can create an IPsec tunnel from SD-WAN to the cloud, to IBOSS, I'm guessing.
That's right. So the way we do this is use SD-WAN to connect your buildings and offices together. Use all the heavy lifting for network security, offload that to the cloud. So we do internet breakouts from the branch offices directly to the cloud service, as well as the end users.
Makes
so you
sense.
can do heavy lifting here. If you do heavy lifting in these appliances, decryption, you're going to run into the same
I guess
thing.
my question is not about this. I agree 100%. My question is, I want to roll tomorrow 200 offices. So I mean, I need to connect 200 SD-WAN boxes. Can you provision to the SD-WAN? Can you work with them? Can you make it faster? Can you potentially automatically have highly available to change tunnels, or like move to a backup tunnel?
That's right. Yeah, basically, if you're doing a project and you're going to do 200 offices, it's predefined config that automatically will configure those routers or those SD-WAN providers that we partner with a ton of vendors. And then what happens is you basically can also save a lot of money because you're going to buy smaller SD-WAN.
Okay, so you can have technical partnership when you can push configuration to SD-WAN.
Oh yeah,
okay.
Absolutely. Yeah, absolutely. And actually, we just announced with the most recent one we announced is with Citrix,
okay,
where just natively integrated.
So last question here: if my SD-WAN box or my router is connecting to two IBOSS different clouds, I'm guessing there's two, active and backup, and the main tunnel is dropping, in which case you will be automatically able to fail over, and in which it has to be a manual work.
Yeah, what happens is those tunnels actually terminate to containerized gateways, different ones. And so they'll automatically fail over and it'll just hit another gateway. And we wouldn't even know, there'll be no blip.
Okay, and you will tell the SD-WAN box to switch to a different tunnel?
Yeah, and it depends on your SD-WAN provider, but they all support this, where they create multiple tunnels, which we support. We receive the tunnel, and they'll automatically fail over to the secondary tunnel or the third or the fourth.
Great. Let's switch topics and talk about users, because we kind of all agree that the future is clients and agents, because we're working right now from homes. So let's talk about your agent. What is support? How it's working? You already mentioned that you're doing all the ports and protocols from the agent, I'm guessing.
We do. Yeah. So basically, what ends up happening is, and I think it's important, is if we're going to get rid of proxy in appliances, network security appliances, it's important that the protection is still there for all of the traffic. So the agent installs and it transparently intercepts and protects the traffic that leaves the computer. And I think that all that traffic gets sent to the cloud service automatically. And actually it works in the background. I can show you here. Let me show you an example here. Basically, it runs in the background on the computer. And basically, when this is running in the background, you don't need this desktop agent. There's a desktop agent that you can enable. Like I have this enabled for myself, because I like to be able to enable disable security. And you can kind of see here, this is an example of our stateless tunneling. There's my IP address. If I have this disabled now, notice we're on video and conference. I'm going to enable this.
Mm-hmm.
Normally, this would disrupt your network connection. So it'd be a dangerous thing because the other vendors, they use stateful tunneling and it starts to cause interruptions and streams. What you're going to notice is I'm going to get no interruption, completely switched my traffic and steered it. I go back here. That was my IP address. There's my IP now.
Interesting.
I just switched to the service, and actually, currently, I'm running through the service. I run this as a desktop. It's hiding here in the background, so I can enable disable it. But
oh, sorry, finish.
Oh, but this is optional, right? Some users don't even want this desktop agent. They just they want it hidden. But if you have an engineer, you have an IT staff, they like to be able to maybe disable it and maybe look at connections. This allows you to kind of look at recent connections going out to the cloud.
I already saw that it's password protected. So in case if you want to eliminate the options to let people disable it, you can do it. I understand.
Well, yeah. It's even better than that. If you want the option to only push this to certain users, like for example, I want the ability here through a policy layer that I want certain users. There's the agents. I want a policy that's linked to me or I want any agent, any software developer. They're the agent settings. I want them to have the desktop app. I don't want them to have the desktop app. Or I want them to have the desktop app, but I want to put a password to disable security or to view diagnostic. So I can do this on a role-based basis. And most other vendors that have the desktop app, it's on or off for everybody, or it's required for everybody. So
last question about the agents. Is there options to do conditional Like if you don't have an antivirus or patching, you're not able to get in and browse.
So today we're not scanning your computer and doing that sort of thing. We do that with partnerships, but it is something we're going to do in the future. We're purely today focused on connectivity. We're part of your overall stack, and we're your platform for secure connectivity. But later we'll be adding more, maybe agent based.
So I believe you already answered this question, but still, what kind of OEM partnership you have with different ways to consume your product? You mentioned Verizon when you were explaining about the architecture. So maybe is there anything else? And how does it work?
So from a full kind of white label, in a sense, Verizon, we're the platform for Verizon Secure Cloud Gateway, which, it's over 1 million incidents a day. We also share intelligence and all that sort of stuff. That's the only one where we have full kind of white label, but actually the MSPs and the telcos are also moving to the platform and using it as well. So we're working with VARs like SoftBank to cover Japan. But we've also done a lot of partnerships where we've embedded malware engines and malware feeds from the partners. So if you buy the malware defense package, you're not only getting, IBOSS Verizon, you're also getting over 36 reputation feeds from all the different feed vendors, about 3 or 4 malware engines, including the Google Safe Browsing database, which means that if you're outside of Chrome, it doesn't matter. We're going to protect all the links against the Google Safe Browsing database. Okay. So we're basically gathering all this intelligence. So a lot of the OEM and a lot of the partnerships is for the engines and feeds. And then the telcos and stuff are using it.
So if I'm a customer on Verizon, I don't need to buy anything. I can just say to Verizon enable the feature and it will be protected?
That's right. You just basically can purchase from Verizon. It's called you would have to add the Verizon Secure Cloud Gateway is what they call it.
Awesome.
Can I do it in the same way directly from you?
You can. Yeah, actually, there's typically if you're going to buy through Verizon, you can send that through Verizon. But you can buy, the thing is with zero trust, it doesn't really matter where you send it, right? So you can. Yeah.
So Gartner defined certain features for secure web gateway. And because outbound browsing, it is a secure web gateway, we wanted to talk about certain features that we feel important. And want to start from URL filtering categorizations. Can you talk a bit more what you guys do in the space? How you guys categorize? Do you take it for somebody else? Do you do it by yourself?
Yeah, no, so that's important. And we own the technology. And just as you look at the categories and all the things you can do with the platform, I think one of the important things here is the service itself is we own the database. We own the category database. We own all of the aspects of it for categorization. It's a massive and extensive database. It's been around for years, covering all sorts of categories as well as speed bumping and those sort of things. So we own our feeds, we share intelligence in the cloud. We auto-categorize as well. We use AI to look at page content. We also have a massive database of trusted sites that are broken down into tons of different categories.
Do you have your own threat intel team that's responsible for this?
We do. Yeah, we do. But when we look at the strategy for malware defense, is we believe that there's not a single malware team that can catch all the malware. It's impossible. It's human intelligence. So our strategy has been to basically develop and deliver the best malware feeds and signatures and signatureless protection from IBOSS. But we know we have to include the other engines, whether it could be anything from Bitdefender, VirusTotal. We need to get as many because it's the human intelligence, and we think that it's the aggregate that delivers the better solution. Actually, if you look at the
do you share with the security community the ones that you identify?
We do. We swap with those. Yeah, basically we collaborate. We swap with those. Yeah, exactly. You look at the latest testing for Myrcom, for example. We scored so highly, but when we look at that, we would love to take all of the credit. But if we look at that score, if it was any lower, we'd be talking to all of our, we'd be collaborating together because we're talking about the top malware houses, the malware defense houses in the world. Something must be wrong. We're looking at files and streams, and we're applying those engines and stream feeds to those data.
Makes sense. So that brings us to the next question: is how you block bad known URLs, or how you actually identify when URL was good, but after time it was weaponized and now it's malicious. How you do that?
So actually, one of the things that's important is that with content delivery networks, the destination itself is important, but you can't purely rely on destination. It's a CDN. And actually, I think that one of the things is like when you think about DNS products, DNS protection, it's good, but it's going to give you great protection from a kind of a DNS perspective. But most of the stuff is going through a content delivery network, a CDN. So how do you know that
IP is not anymore a function that you can rely on?
And actually,
right?
Yeah, even the domains are very tough because it's, it says Dropbox.com. How do you know that that's not a malware file, right? But as what we've done is we've taken a position of first, make sure you look at the content, analyze all of the content, all the files, the zips, the PDFs. That's through the proxy. Second is let's look at all the strings. That's the firewall. Let's look at destination IP. Let's intrusion prevention. Let's run against the feeds against that. So we use a combination of different things. And so as soon as, even if it's a trusted URL, we're still going to look at the content anyways. Second is we're then putting reputation scores on the destinations from what we're seeing, as well as what our vendors are seeing, because they're feeding us in real time. So as soon as they pick something up, it gets blended into our database, and we
So you rely on the signatures that you are getting from this data source,
as well as the ones that we're discovering.
How would you detect and block malicious content hosted within the site, right? Something like Flash, something like malicious JavaScript that utilizes the next zero-day vulnerability in the browser.
Yeah, so when we look at there's a big debate between firewall or proxy, which one's more important. Of course the firewall vendors, Palos, say the firewall's the future and it's what's needed, and then the proxy vendors like Zscaler, they'll say proxy is what's needed. We say you need both. Firewalls deal with streams, proxies deal with files. Before we give any content to any user, we're going to unzip that content, scrape the page. We're going to look at all the JavaScript, and we're going to run that through analytics, signatureless protection. If there's any content that's malicious, it's not going to make it to the user. We're going to strip that content out. And so I think that we're looking at not just the destinations and the destination IPs and URLs. We're looking at the actual content, and if we find anything, we're going to strip that out from the user so that they're never going to see it. And so we're able to kind of get to the bottom of what, make sure that they're protected before it even
makes it to the computer. Remove the malicious portion, but serve the healthy portion of the website to that user. Or you would block completely the access to this website. What would you do?
We'll basically strip out just the malicious content. So we'll let the good content through, and the page, if there's malicious JavaScript, we'll strip that part of the content out, and they'll still get to the page without that content. Yeah, we analyze literally every single piece of content that might make it to an end user before they receive their content in its entirety.
Nice. As part of outbound browsing, we feel it's important to identify cloud applications. So basically, understand what's sanctioned and what's not sanctioned. Shadow IT. Tell us, what do you guys do in shadow IT space, and how you can tell the customer what they're running, what they're using?
Yeah, I think that area there is probably the most important, because I think there's a lot of confusion when it comes to API-based CASB, for example. API-based CASB connects. Yeah, if you think of it, what does API-based CASB connect to? It connects to your business applications that you own.
Yes.
What does shadow IT cover? Is users using their own personal Dropbox. But you can't connect your API-based CASB to someone's personal Dropbox. I mean, in essence, when you think about it, sure, it's nice, but it's not really covering the core problem, which is shadow IT people are copying stuff to personal Dropbox, maybe by accident, maybe on purpose, doesn't matter. So we focus a lot on inline CASB and inline DLP, where you can create all sorts of different signatures, headers, where we inspect all the content. So if you're uploading a file to Dropbox, not only can you block that traffic, but we can analyze it, look at the person, are they even allowed to go there? And that includes the personal and the business. We're gonna look at both of them. And so then we tightly control it with this, like things like tenant restrictions here. What's nice about tenant restrictions is if you're using Office 365, we can force that device, that company device, to use your Office 365. So the data that leaves that device, the only place it can go is to Office 365 that you own. So now you can scan for DLP in there. Or if you're using something like Google Drive, which is also really nice, you can say, if you're using Google Drive, it better be my company's Google Drive. If it's personal, it'll prevent that. You can't even get there. So it's tight control of the data path, the network data path between the device and the destination to force them into controlled and trusted locations, covering all of the shadow IT and things like that. We're actually even taking it to the next step where you can actually create your own app signatures. You can create your own applications, define them, just like you could, the original App ID concept. But think of App ID on steroids, where I can actually create any pattern I want, looking at any part of the payload. And this allows me to basically inspect, inject headers, prevent data loss, anything I want to do with even applications that I feel are important. So.
Great. What about QoS? Can I do bandwidth control on YouTube or any other streaming applications?
Yeah, so one of the more popular options, we have all these bandwidth pools where you can shape traffic and stuff like that. But a very easy option under our CASB, it seems very small, but it's a big deal, is we could do something as simple as prevent HD playback on YouTube. That little change there, you could do it per group, I'll tell you, saves an enormous amount of bandwidth. It makes them play it in standard definition. So now the users can get the experience, but they're not saturating the entire network. Because of course, YouTube wants to default to HD for everything.
Yes.
Right?
Yes.
And so that little change right there, without even doing complex roles, saves you a lot of bandwidth. But then if you want to take it a step further, you can create all sorts of bandwidth pools and things like that. So you can go as far as you want in terms of pooling and shaping.
What about DLP? I know it's a big topic, so I don't want to spend it could take an hour, but let's in a couple of minutes explain what you guys do there.
Yeah, so you can go in and create rules for DLP, where again we're unzipping a file, scraping the spreadsheet for text, looking for PII. You can apply it to different sources and destinations, right? And then actually when you get here to the criteria, we'll look for socials, we'll look for all sorts of different patterns. We'll take logging thresholds and samples, and then finally we can do an action, make it look like the page.
Can you understand tagging from other vendors?
Yeah, basically that's very, very popular. You basically put the tag into the DLP platform, and it'll actually recognize that tag. So you can allow or block based off that as well.
Awesome. We done with the questions about security web gateway?
The next one is about how I would POC your solution, right? Let's say I'm a security professional working for a company, I'm looking at solutions. What would I do to start the POC to kind of experience how it works, experience what kind of controls it gives me, and what would be the process? Would I need to just go and register somewhere, download quickly a client, and I'm up and running, or I need to install something more complex?
Yeah, remember all the security functionality happens within the cloud service. So no matter how you test the POC, you could test it any which way you want, and eventually you could do tunnels, you can do whatever you want. I had a customer, there was a large network, 75,000 devices, and I said, look, how would the POC work? And we're really desperate. I said, you could be running in 60, literally within the next 5 minutes, you can actually try, get going. And they said, if that's true, I have my IT guy here, and I want in 5 minutes, I want you to put on 200 devices on this. The IT guy went there, came back within an hour and said, I love this thing, let's buy 75,000 devices. And I think the easiest way I would recommend, we have a POC guideline that you walk through that just basically, it's more like training, is grab the agent. Of course, you could push these with Active Directory, just install it on one computer. And now you can test everything, because remember, you're connected to the service. You'll be decrypting traffic within 60 seconds with username and groups and everything. You'll walk through all the processes. And then when the time comes that you want to use tunnels and do other things, just the same features. Everything happens in the cloud service. You can go and plan all those things out. And maybe you decide to just push the agents to everybody.
And you also have I can see you have an agent for Linux.
Oh yeah, actually this AWS, Azure variants, all sorts of the Linux, virtually every Linux variant.
What about technology partnership? You already mentioned, I believe, FireEye, CrowdStrike, and McAfee. Any other partnership you guys have with other vendors?
Well, we're one of only two networks trusted security vendors for Microsoft, where we integrate with their Microsoft Cloud App Security. We're also a cloud solutions provider for Microsoft, and we're doing a lot of things with Microsoft. But basically, when it comes to Microsoft, we have the one click for virtually everything. Anything from linking your, making sure that the Office 365 domains don't break, to MCAS, which is Cloud App Security, to Virtual WAN. We're doing a lot of stuff now with Citrix and other vendors. So there's just a variety of malware engines and connectivity vendors that we're partnered with.
What would be the 3 reports or the 3 major metrics right? That I can look at and see clearly what was the state before I started using your product and what was the state after I started using your product, right? And what would be the thing I will take for a meeting as a CISO and share with my board.
Yeah, absolutely. So I think there's a few, and when it comes to, I think the user risk is a big one because it generates the risk reports that are needed that you can provide to not just CISOs and IT, but you can give it to HR. It works really well, which summarizes who's high risk, what was the risk, what was productivity, what was searched for, those kind of things, and also could go further if you want to go even deeper. You can go to the links and stuff like that. The other one here is when we think about dwell time, like infected devices and dwell time, we have a really nice report that shows how you trend with malware, how you're trending and reducing risk, gives you the list. This tends to be very popular, not just for remediation, but also to preview how are we doing? Are we taking hours to remediate when we see a problem? Are we on top of this, on top of our stuff? And then lastly, from a productivity, there's the health of the users. When the users are remote and connected to the service, how much throughput and bandwidth are they using? That's another big one. Because I think that correlates to productivity. Because if you have, I think bandwidth is the oxygen of cloud applications. If you don't have bandwidth, your cloud doesn't exist. And so that's why we believe that connectivity and what we're doing is very important, because we want to provide the fastest connections to those applications, and to show that you can consume more, especially when people are remote, means that they're working faster and more efficiently.
If you consume more bandwidth, that's the same.
Yeah, if you're working from home and I can see that they're consuming more bandwidth,
and it's not YouTube.
It's all, yeah, right. Yeah, exactly. With the reports, it's not YouTube. Exactly. But that's where we have all the templates here. Full reports, executive reports, IT reports. You can even create your own if you don't want to do the executive. You could do the cover pages. We've customized all of this, so that makes it really easy for you. Yeah, I can see Lisa. This is all the domains. What was blocked? That's what was searched for. This was high risk. That was productivity loss. It just makes it really easy.
Yeah, excellent. Well, thank you for sharing that. I think that concludes our major list of the topics that we want to discuss, and it brings us to the next stage in our podcast, which is more like open topics.
So I have a few questions, but before this, Paul, anything else you want to cover?
No, I think we covered a lot. But one of the interesting things is, remember, I turned on the service halfway through the podcast. You didn't even notice.
Yes.
So I think that's a pretty interesting. Just the speed and just how transparent it is. You just don't even know it's there.
So I asked you during the podcast about IoT. So if I have an IoT at home and IoT in the office and there's no tunnel, how would I connect the IoT device to the platform?
Yeah, it's easy. Use the GRE or IPsec tunnels if you're going to go to the cloud service. If you have private cloud, remember it's no different than what you're already using. You can just, if they're proxying, they're going to be proxying. If they're using WCCP or ITD from load balancing or F5, it's going to be F5. That's what we like about it. We're not telling you to use one way or another. We're giving you that flexibility as an IT administrator to decide what's best for you.
Gotcha.
And to figure out. Yeah.
What's your take on DNS security?
So look, we have DNS security here. So if you're going to use DNS, you can put your DNS. We'll run it through all the feeds. The difference with DNS is it doesn't give you the payloads. It's just the queries. And so my perception is it's a great technology for your guest networks. Why? Because when a guest jumps on your network, we can give them the DNS and we can protect those devices without touching them. I don't think it's the best solution that you might use for your company-owned devices, because I think you should scrub the data. You need to scrub the zip files, the PDFs, because we see so many content delivery networks. Take a look at just one example here. I'm going to pull just a random website and say, let's say it's CNN or something like that. Every vendor is using CDNs, and some of these CDNs happen to be Cloudflare. You can't even tell which site is which, and you're grabbing so many CDNs and a lot of these don't even have domains. So like the DNS is good. And I think it's a good overlay as well. But I think it's great for guest networks. I think it's probably if I had a choice, I'd probably use that for guest networks just because it's easy and low touch. And then, but it's nice that you can mix and match between.
I guess last question I have. There is a lot of URLs and domains that are uncategorized. And there's a lot of talk, should I block them or not block them? I cannot block them because it's going to generate a lot of probably false positive. Then there's a discussion, if it's uncategorized, what can I do? Maybe I do browser isolation or can do something else or block download. Tell me your take and your guys' direction in this case.
Yeah, so we give you the option. You can use the auto categorize. It'll just auto categorize them. It'll use AI, so it's not going to be, it'll be as good as AI can get for auto categorization. I think that's a really good choice. And then we also have unclassified, where you can decide unrated, basically, where you can decide what to do with those sites. If you want to block them, bump them, it's really up to you.
Do you think
And you can do
browser isolation is potentially the future of uncategorized traffic?
I think it could be a good choice for risky sites, but I think the challenge I have with remote browsing in particular is applications are moving into the web browser. The software that I like, if you think about G Suite and Google's, the application is not running on the server, it's running in your browser, but remote browsing says it's going to render the page and send it to you, and maybe a copy of it. But it's contradictory to where technology is going. Technology is saying, we're not going to send you copies of stuff. We're going to load the app into your browser, and that app is going to request content dynamically as needed. Actually, This is an app running here, right? So we kind of feel that it's good for these risky sites. If you want to auto deposit, and we can do that. We can auto deposit you there, but it's not a long-term strategy that's going to, I think be sustainable when virtually every application eventually runs in your SharePoint and everything else runs in your browser as a full app. And then lastly, I would say that there's always different technologies for malware defense, sandboxing, signatureless detection, actually AI models like CrowdStrike uses and Cylance. So there's no definitive answer to malware, right? It's just different techniques, and you can layer as many as you can. And I think that's a good technique that you can layer on top and use as a strategy.
You just remind me another question. TLS 1.3. Is it a problem, not a problem?
Well, I think that's probably the biggest ticking time bomb for any appliance, inline appliance. If you have an inline appliance currently doing decryption, as soon as TLS 1.3 comes to play, you're not going to be able to selectively decrypt. And what's going to happen is all of your network traffic will need to be decrypted, and the load on that appliance is going to bring it to its knees.
Can you explain why the load is more?
What happens with TLS 1.3 is that the traffic is encrypted from beginning to end, meaning not even the certificates are exposed. And so inline appliances are relying on the certificates as well as SNI, looking at the certs and destinations to figure out whether they should be crypted or not. But what happens with TLS 1.3 is there's nothing to key off of from the first SYN packet to the end. And so what happens is if you're decrypting, you either have the choice of everything decrypted or not. But there's things like pin certificates that you can't decrypt. It breaks applications. And so there's no choice but to have selective decryption. And so what happens is as soon as all the traffic gets decrypted, the amount of CPU, compute, now goes to the roof because they can't bypass decryption on trusted traffic. And so, for us, what we do is we basically are set up for TLS 1.3 because what we do is we overlay proxy on top of tunneling so that in the agent, and we can actually see the domains and take care of selective decryption and actually in the cloud, you can decrypt the entire internet, every single destination. There's no compute limitations. But I think that it hasn't been mainstream just yet, but we believe that as soon as that happens, that's a wave that a lot of people are ready for. And when that occurs, that it's just going to be fire drills, just like COVID probably was for a lot of companies.
Great. Awesome. I don't have any more questions. Dimitri, you?
No, I'm good.
Awesome. Paul, any questions to us?
No, it's great talking to you guys. Yeah, good being here today.
Paul, what is the best way for people to find information if they want to learn more about IBOSS, POC, the technology?
It's easy. Just go to iboss.com. There's all the phone numbers, web form, and everything you can submit. You'll get a call back typically within 30 seconds.
Awesome. Paul, thank you very much. It was a pleasure.
Please remember to subscribe to our podcast and join us for our next episode.